In terms of the rate of the E2 elimination, there's one important distinction where it diverges from the SN2. So in many ways, it's like SN2 in that we want a strong base, strong nucleophile, but in terms of the organohalide that's reacting, more substitution means a faster E2 elimination. So what this means is that for E2, tertiary halides are better than secondary, which are better than primary. This is the trend for E2, E1, SN1. Only SN2 follows the opposite trend. All right, so let's look at why E2 favors this trend and then compare it to SN2. So here we're going to compare a primary halide and a tertiary halide, and I'm going to use a small base like methoxide. So basically, this small base can easily attack any hydrogen on the molecule. Now, in the case of this first example, it's going to attack this beta hydrogen. In the case of the tertiary, it can attack the beta hydrogen on any of the methyl groups. I'll just draw in one right here. So the way this would work is like that, and the products we get will be these alkenes plus the byproducts. So what you want to think about is the fact that in terms of reacting with the beta hydrogen, it's easy for the small base either way. Because in this first case, it's just attacking this hydrogen here. In the second case, it's not like it has to go to this substituted carbon. It's only going on the hydrogen near that substituted carbon, so it's not really a hindered site. So that can attack there or there. So what really drives the rate of this reaction is the product that's formed. And in the case of the two products, the first one we get a mono-substituted double bond, the second one a di-substituted double bond. It's a more substituted alkene, so that's a faster elimination. Now let's make a comparison to the SN2 reaction. In the SN2, let's use methoxide again. There's a big difference here. When it reacts with the primary substrate, it's going to attack this primary carbon, which is fairly easy. But when you come down to this tertiary carbon, because that nucleophile is attacking the carbon that's changing substitution, that's going to slow down the rate. That part's very difficult. So for that reason, when we have a more substituted carbon, that's going to be much slower, or in this case really doesn't happen. Less substituted carbon is going to be much faster.